Hello, today I will be introducing and covering parallel lines and angles created by transversals, which includes the three-parallel theorem and the midline theorem. A transversal is a line that intersects two pairs of parallel lines to form pairs of congruent and supplementary angles. EF is the transversal here. When a transversal cuts across parallel lines, several types of angles are formed: alternate interior, alternate exterior, vertically opposite, corresponding angles, complementary angles, and supplementary angles. When two parallel lines are cut by the transversal, the pair of angles formed interior of the two parallel lines and each on the opposite side of the transversal are called alternate interior angles. They're represented by the number 1. Conversely, the pair of angles formed exterior of the two parallel lines and are each on the opposite side of the transversal are called alternate exterior angles. They're represented by the number 2. Then we have vertically opposite angles. Vertically opposite angles are the two angles opposite to each other where the transversal intersects one of the two parallel lines. They are represented by the number 3. Then corresponding angles. Corresponding angles are a pair of angles that are in the same position on each parallel line cut by the transversal. They are represented by the number 4. Complementary angles are two angles with a sum of 90 degrees. Supplementary angles are two angles with the sum of 180 degrees. There are two theorems I will cover. The two theorems are the midline theorems and the three-parallel theorem. This is the midline theorem. Let's say we have a question that gives us trapezoid ABCD. There are diagonals that cut across the mid-segment EF, and it cuts EF into three smaller segments, X, Y, and X. And we have to find the lengths of X, Y, and X. So using the midline theorem and looking at triangle ADC, segment EK should be half of 15, which means X plus Y is 7.5. Then if we look at triangle ABC, segment KF is the mid-segment of triangle ABC. Therefore, X is half of 10. Therefore, X is 5. Knowing X is 5, we can then calculate the length of Y. We know mid-segment EK is 7.5, and we know that EK is X plus Y. Therefore, to calculate Y, all we have to do is subtract 5 from 7.5. Therefore, Y is 2.5. Therefore, the length of X is 5, and the length of Y is 2.5. 5 plus 2.5 is 7.5, and that is the length of mid-segment EK, and that is half of DC, which shows the application of the midline theorem to an example problem. Here we have the three parallels theorem. The three parallel theorem says that the length of the segments formed by the intersection of transversals on the parallel lines have the same ratio. For example, on transversal AB, segments with length 2, 6, and 8 are formed. The ratio of 2 to 6 is 1 to 3. This is the same ratio for 3 and x on transversal CD. 3 must be 1/3 of x. Therefore, x must be 9. Back to transversal AB, the ratio of 2 and 8 is 1:4. This is the same for 3 and y on transversal CD. Therefore, y is 4 times of 3. Y equals to 12.